go into the cosine rule, let's look at the ambiguous case of the sine rule. The ambiguous case of the sine rule is studied at the higher level only. It is not because the discussion is difficult, but only that at this juncture, most HL students have also studied the unit circle and looked at trigonometric ratios for angles that are greater than 90 degrees, okay? Let's take a look at this. We will look at it through a question because that makes life easier, makes you understand it better. So here is the problem, and it is a confusing problem, as we will see. In a triangle CDE, angle C, basically angle DCE refers to angle C because of that cap there, is 25 degrees. The side CD is 7 and the side DE is 4. By the way, this is also the IB's notation for the length of side. There will be programs where we draw a line at the top. If a line is drawn at the top with an arrow, then it's a vector, of course. But if a line is drawn and there's no angle, then that refers to length of side. So the IB's way of indicating that we are talking about the side of the length of side of a triangle or of a whatever length of an object, we use those square brackets there. Okay, so length of side CD is 7, length of side DE is 4. The question is to sketch and label the triangle, part A. Part B is to find the angle CED, and lastly to find the length of side CE. Okay, now I can bet that if I give you this question, in fact I challenge you to pause the video and try to sketch this diagram. As a matter of fact, there are two possible triangles you could draw that would match this the information that is given. All right, so but let's take a look and see what's going on. So that's the information given to us. All right, here is one likely diagram that you might find that you have drawn. Okay, you can see the length of side CD is 7, side DE is 4, and the angle C there is 25 degrees. Okay, if you try to draw this if you try to draw it, it is possible that you came up with something completely different. All right, still satisfying these conditions. All right, so now that we've drawn this part A, let's look at part B, which was to find angle E there. Angle CED is angle E there. So by sine rule, straight away, the sine of angle E divided by the side opposite must be the same as the sine of 25 divided by 4. Okay. If we rearrange, make sine E the subject of the formula and use a calculator to find those values, we can find E directly by looking for the sine inverse of this expression on the right-hand side. And if we do that, we get that's the value of that expression, and look for the angle whose sine is 0.73958, and that should be 47.7 degrees. Try it out and confirm that that's the angle. So that's telling us that this angle here is 47.7 degrees. Now that we have that angle and we have our 25 there, it should be possible for us to find angle D. Okay, we use our knowledge of the fact that the sum of the interior angles of a triangle must be 180. So the remaining angle there must be 180 minus these two. And the sum of those two is 72.7. So if we do that subtraction, we get 107.3 degrees. Okay, so that must be angle D, 107.3 degrees. And with the knowledge of that angle, it is now possible for us to find the length of side CE using the sine rule. So by sine rule, okay, if we go for the sine rule again, the sine of 107.3 over side CE must be equal to the sine of 25 over 4. As we've shown there. If you rearrange that and find side CE on the calculator, you should find that it is approximately 9 units. Okay, this symbol of approximation is important in the IB program. if you're writing an IA, your values, if you are investigating some quantity, the chances are the values you get are approximations, and it's important that you're indicating that for symbols and notation, okay? Okay, and so the length of side CE is 9 units. All right, we are done, aren't we? Well, what does he say? So we want to ask ourselves, is 47.7 the only angle whose sine is 0.73958? Is it only 47? Now, if you are an HL student, then you know that there are in fact infinite angles, okay, with a sine ratio of 0.73958. There are infinite of them. However, within a triangle, a three-sided figure, okay, that angle cannot be greater than 180, all right? And given that this is already 25, all right, that angle has to be less than 180. So then the question is there another angle less than 180 and that is not, which is not 47.7? Do we have a second angle that is not 47.7, okay, and lying between 0 and 180? And to answer that question, we are going to look at a simulation. So here is the triangle we just looked at with the different sides, 7, 4, the angle that we got of 47.7, and the other one of 107.3. So this is basically the triangle we've been working with. Now the question is this the only potential angle for which these dimensions of 25, 7, and 4 exists? And we've determined that there is another angle that will also give us the same values of 25 for angle C, 7 for the side CD, and 4 for the side DE. And how do we find that? So this is a GeoGebra animation. So what I have there, I'm going to change that angle here. All right. So if I change this angle here, we can see that what happens is side D is changing around this circle. All right. So the distance 4 remains the same. The distance 7 remains the same. This angle is changing, but eventually it starts reducing again. So right now it was increasing, and now it's decreasing again. So there's going to be a point when that angle becomes 25 again. When is that? So that's 28, 27, and there is a point when it becomes 25. So clearly there is another value of angle E for which this is 25, that is 7, and this is still 4. Okay? So it means that given this information of angle C being 25, side CD being 7, and DE being 4, being given that information is not enough to tell us the exact shape or the exact size of that triangle. So we've had a case where we have 4, 7, and 25 degrees, but now side CE is 3.7 units. All right, the previous case, let's just get back there. The previous case was the length was 9, the length of CE was 9. So there are two different possible angles, E and side CE, for which the information given to us was valid, all right? And this is why we refer to this as the ambiguous case of the sine rule. So when we are asked to calculate these values for the ambiguous case, it is important that we are also given all the information, or if all information is not given, then we have to find both cases for which the information given will hold, okay? All right, so now then let's get back to the other side. Okay, so based on the simulation we've had, let's try to justify this mathematically. Okay, a unit circle, if we draw a unit circle is a circle of radius 1. It has got 4 quadrants. All right, this is the first quadrant, the second quadrant, third and fourth. We count the quadrants going anti-clockwise. So in the first quadrant, all trig ratios are positive. Sine, cosine, and tangent are all positive. Here only sine is positive. Here, in the third quadrant, all the tangent is positive. And in the fourth quadrant, only the cosine is positive. We are not spending time on that. But our 47.7 degrees there lies in the first quadrant. This is 0 degrees, 90 degrees, 180, 270, 300 is the same as 0. So 47.7 must be within the first quadrant here. So we can indicate 47.7, okay? But then in the second quadrant, we can map this 47 on the other side, right? So we can map this line there so that this angle here is 47.7. The height of this point must be the same as the height of that point according to the definition of sine on the unit circle, all right? And so there is another angle here that we need, okay, which we can find by taking 180 and subtracting 47.7 degrees. So if we do that, we get that there is another angle that E could take, which is 132.3 degrees. So if we draw the triangle now, the angle E is going to have to be 132.3. And if you've seen the simulation, we had a diagram that looked exactly like this, all right? Your task now, what I would like you to do is to try to confirm the figures we've seen in the simulation, confirm the length of CE and the angle D by some calculation. So confirm through calculation the values of side CE and angle D. This is your turn to try out the question. So why do we refer to this as an ambiguous case of the sine rule? It is because we can be given a set of information, all right, and asked to calculate angles or calculate the side of a triangle. And it turns out that there is more than one possible triangle for that set of information, okay? This is the only reason why we refer to this as an ambiguous case. All right, so before we finish, let's look at circumstances under which you might identify an ambiguous case of the sine rule, all right? So an ambiguous case arises if, 1, you're given 2 sides and a non-included acute angle. Remember that term, non-included. I'm going to explain that with a diagram shortly. Or, and the side opposite to the acute angle is the shorter of the 2 sides that are given. So here's the diagram I'm talking about. So we have a situation for the ambiguous case if you have 2 sides, 7 and 4, and a non-included acute angle. So remember, if we're given this side and that side, then the angle between them is called the included angle. But this angle is not given. Instead, it is that angle that is given. So we are given the non-included angle. The angle between the given side is called the included angle, and because we are given one of the other angles, such a scenario will result in an ambiguous case if at the same time the side that is opposite to the acute angle, the given side that is opposite to the acute angle, is the shorter of the 2 sides that have been given. If this scenario arises, then you have an ambiguous case of the sine rule, all right? We will look at this diagram again, especially that simulation, after we've discussed the cosine rule. So HL students can then start looking at how this a question in paper 3 might result from this in calculus, all right? We will revisit this again after the cosine rule, okay? All right, I believe that this is the end of this lesson. See you on the other side for the cosine rule.